All right, welcome to 11.3, Applications and Trig Identities. Okay, so in the past, in 11.1, we talked about trig ratios and sine. So trig ratio, remember, oftentimes we'll have a triangle, something like this, and we'll want to find the trig ratio, so like sine of theta. Okay, so when you have your answer, just make sure it's always going to be like a fraction. Okay. That's the only time where you need to have it as a fraction is when you do the ratio. Okay. We also talked about sine, cosine, and tangent. If we had a triangle, oftentimes we would have like an angle and a side, like 5 and I don't know, 25 or something, and we'd need to find a missing side. Okay, so we'd want to use SOHCAHTOA. SOHCAHTOA. Okay, or oftentimes we will have, I don't know, maybe like 4 here, but we want to find this angle. Okay, and we talked about that and how we'd use sine inverse or cosine inverse or tangent inverse. So we'd only use inverses when we try and find an angle. We use sine, cosine, and tangent when we're trying to find a side. All right, so if you need extra help with that, just feel free to look at the previous videos. All right, so here we're going to apply SOHCAHTOA on applications or word problems. Okay, so for example, for all word problems, draw a picture. Okay, that will be part of your points. The height of a tree is 15 meters. Okay, so we have this tree here, and this is 15 meters. Okay, and then it says to the nearest degree, what is the angle of elevation of the sun? So angle of elevation, we'll need to talk about that at the top. Okay, and there's also angle of depression. The angle of elevation of the sun when it casts a shadow that is 9.3 meters long. So here we'll maybe draw our shorter tree, our shadow. It's all filled in because it's a shadow. Okay, this would be 9.3. And it has the sun over here somewhere. Okay, it's circle, not a cloud. Okay, and we want to find the angle of elevation. Okay, so elevation, angle of elevation, if we do the same kind of triangle here. Angle of elevation is the angle that goes between the horizontal and the hypotenuse. Okay, so this would be angle of elevation. Okay, depression would be something like where we have the horizontal and the angle here. That would be our angle of depression. Okay. All right. So for this problem, this would be our angle of elevation. And that's what we're trying to find. So here, if that is our reference angle, this would be our adjacent and opposite. And which of the SOHCAHTOA uses opposite and adjacent? It would be tangent. So tangent of your angle is opposite over adjacent. Okay, and we want to find this part. So we do tangent of theta equals opposite over adjacent, 9.3. Okay, and we just need to solve for theta. Last time we talked about how if we need to get this by itself, we would use the inverse, tangent inverse on both sides. This, so you'd end up getting theta equals the tangent inverse of 15 over 9.3. And when we do that, we plug that into our calculator, we would get 58.2020 degrees. Okay, make sure you can use that or do that on your calculator. If you get a different answer, again, chances are that you have it on radians instead of degrees. Okay, all right. Okay, before I go on, let's fill in this part. Compared with parallel lines. So if we have two parallel lines and we make a transversal, okay, I mean, you can make a triangle with both of these, all right? So here for this angle, this would be our angle of elevation. Okay, and this would be the angle of depression. So here we learn that the angle of elevation and the angle of depression are always exactly the same. Okay, so like for example, this problem, if we had this triangle, we would know that this angle is also 58.2. So the angle of depression and the angle of elevation are the same. The thing that sometimes you may run into that you would get this wrong is if you use these angles. If you use the angles that don't use the horizontal lines, okay? So that would just be cautious. Make sure you use the horizontal line. Use this horizontal line and the hypotenuse, okay? And then we would get that angle of depression or the angle of elevation, okay? And we know that they're congruent because alternate, spelled that wrong. Alternate interior angles are congruent. Alternate interior. Okay? All right, so let's look at this meteorologist problem. All right. He reads a radio signal to get information from a weather balloon. Okay. The last alert indicated that the angle of depression of the the weather balloon to the meteorologist is 41 degrees. Okay, so we have this gosh, I can't do it. The weather balloon, okay, and the angle of depression here would be 41 degrees from the meteorologist. So here's maybe my meteorologist. Okay, and the balloon was 1,810 meters away from his location on the diagonal. Okay, so if they say on diagonal, would be using that hypotenuse. Okay, if it was by height or distance on the horizontal or whatever, then we'd use those sides. Okay, to the nearest meter, how high above the ground is the balloon? Okay, so we want to find this height. All right, or you could also use this height because we know, that this angle right here is the same as this angle. Okay, the depression and the elevation, those are the same. Okay, so you could use it either way. You get the same answer. So here would be our angle. This would be our adjacent, opposite, and hypotenuse. We want to find this opposite side. Okay, or either way, if you use this angle, we'd use adjacent and opposite. Okay, so we'd be using opposite and hypotenuse, which is so, Katoa. We'd use sine of 41 is equal to opposite over hypotenuse. Okay, so we would multiply both sides by that. Okay, that would cancel. This is O for opposite. Maybe that's why they want you to write it as 3 letters. Okay, and we'd end up that the opposite, or that height, is going to be 1187. Okay, wanted to round to the nearest meter. So, okay. All right. Next one. A sonar operator on an anchored cruiser detects a pod of dolphins feeding at the depth of 255 meters directly below the ship. Okay, so maybe I draw my ship. Here is my guns, because it's a cool cruiser. Okay, and the dolphin, however you draw a dolphin, it looks more like a fish, but that's my dolphin. Okay, and they tell us that it's 255 meters directly beneath the ship. Okay, that's pretty deep. I don't know if dolphins actually go that deep. I have no idea. Okay, and then it says that the cruiser travels 450 meters west, and the dolphin remains at the same depth to feed. So what is the angle of depression? Okay, so here's our horizontal. This would be our angle of depression. Okay, so based on that reference angle, this would be adjacent and opposite. So it would be using TOA. So tangent of that value, x, is equal to opposite over adjacent. Okay, to get that angle by itself, we would use the tangent inverse, both sides. And we get x equals tangent inverse of 55 over 450. That's 255. Okay, and that would end up giving us 29.54 degrees. Okay. And then the next question is, what is the distance y between the cruiser and the pod? So let's say this would be y. That's the distance between the cruiser in the new location. So here's my cruiser. He moved over there. And we want to find that. Okay, so there's two ways we can do this. We can use Pythagorean Theorem because we know the two sides. So we could do 255 squared plus 450 squared equals y squared. You can square root both sides. That square and square root will cancel. And then we could plug this all into our calculator and get y equals 517.23 meters. Okay? Or you could use trig. So now that we know that this angle is, we could use opposite and hypotenuse or adjacent over hypotenuse, and we could solve it that way. Okay? All right, last one. Ladder manufacturing recommend that its ladder to be used at level ground. Okay? So maybe we'll have level ground and we'll have maybe a ladder. Okay? Recommends that the ladder be used on level ground at an angle of 72.5 degrees to the horizontal. So here's the horizontal. Okay, so this would be 72.5 degrees, right? Or that would also be, if you wanted to call it, as the angle of elevation. Okay, at that angle, how far up the side of the building? So we want to find the height of this building, given that the ladder is 14 feet. Okay. All right, so here we have our angle. This would be the hypotenuse. We want to find the opposite. So here would be using because sine uses opposite and hypotenuse. So sine of 72.5 is equal to opposite over hypotenuse. Or we'd get 14 sine 72.5 equals 0. So if we multiply, or not, okay, opposite, not 0. Okay, we'll multiply 14 on both sides. That's what we get here. And we'd plug that in our calculator, and we would get that the opposite side, or that height, is 13.35 feet. All right, so we're on the second half, trig identities. Okay, there's 3 identities we're going to be going over. The first is a relationship between sine of an angle and cosine. Okay, so we want to find out what we're going to put in those parentheses to show that they are equal to each other. Okay, so first let's identify each trig ratio. So if we're using angle A, cosine A, let's label adjacent, opposite, and hypotenuse. Okay, cosine of A is adjacent over hypotenuse. That's for our TOA. Okay, so we'd use adjacent over hypotenuse, which is 7 over 24. Okay, while we're still using the same angle, let's use sine of A, which is an opposite over hypotenuse. Okay, and then we'll just use a different angle, angle C, to do the other two. Okay, so again, adjacent, opposite hypotenuse. For sine, it's opposite over hypotenuse, which is 7 over 25. Sorry, here this should be 25. Okay, and then cosine is adjacent over hypotenuse, which is 24 over 25. Okay, and as you notice that we get the same answer depending on what angle we used. Okay, so let's see if there's a relationship between angle C and angle A. So we know that a triangle altogether, all the angles add up to give us 180. So if we did angle A plus angle B, which we already know is 90 degrees, plus angle C is equal to 180. Okay, we could simplify that a little bit, and we can get angle A plus angle C is equal to 90. And then let's just solve one of them for the other. So angle A is equal to 90 minus angle C. All right? So as we notice here, we have cosine of C. That gives us one of our answers. But if we plug this in for sine of A, that tells us that we can use the same angle, but just subtract that from 90. So if that makes sense, sine of theta is equal to cosine of 90 minus that same angle. Okay, same thing for cosine of theta. That's equal to sine of 90 minus theta. Okay, so we'll be using this. This is kind of like this is kind of a thing by itself. Okay, and then let's see if we can answer some of these questions using that information. Find the equivalent sine or cosine. Okay, so for example, this one we have cosine of 61. That is equal to sine of 90 minus 61, or sine of 29. Okay, and we get the same answer. If you wanted to check, you could plug those both into your calculator, sine or cosine of 61 and sine of 29, and you'd get the same answer. Okay, same for sine of 75. Okay, this would be cosine of 90 minus 75, or cosine of 15. And then finally, sine of 36 is the same as cosine of 90 minus 36, or cosine of 54. Okay. Next, there's some sort of relationship between the ratio of sine of theta and cosine of theta. So if we make that ratio, sine of theta over cosine theta, okay, and we want to prove that that is equal to the tangent of theta. All right, so how we can do this is we can realize that sine of theta, or x, or whatever you'd like to call it, sine is opposite over hypotenuse. Okay, and then we're going to divide that by cosine of theta, which is adjacent over hypotenuse. Okay, and then we can simplify this. We can, there's different tricks you've learned in the past. How I'm going to do this is I'm just going to multiply top and bottom by the reciprocal of the denominator. So that would be h over a. Okay. For the denominator, we'd have a and a, that would cancel, and h and h, that would cancel. And in the numerator, we would have the h's would cancel, and we'd end up getting opposite over adjacent. Okay. You've also had problems perhaps where you just flipped the denominator and brought it to the top. So that could be the same thing as opposite over hypotenuse times hypotenuse over adjacent. Okay, that would cancel, get opposite over adjacent. You get the same thing. Okay, and what do we know about opposite over adjacent? Well, that is tangent of theta. Okay, so our relationship here, tangent of theta is equal to sine of theta divided by cosine of theta. Okay, and the last one is the Pythagorean identity. Okay, so this identity, and I can talk to you about that, about how that is related to the Pythagorean, what is it called now? I can't remember. Pythagorean, a squared plus b squared equals c squared. Pythagorean, gosh. Pythagorean. Anyways, it'll come to me, okay? Oh, my word. Anyways, this is sine squared of theta plus cosine squared of theta is equal to 1. Okay, and this is the same thing as if you did sine of theta squared plus cosine theta squared equals 1. Okay. Okay, how that comes from is unit circle, and you'll be learning about that in Sec 3. Okay, so if you have any questions, I can show you how that came from. But we'll just hang on to that and just remember that. Okay, you may see the Pythagorean identity written as cosine squared of theta equal to 1 minus sine squared of theta, or sine squared of theta equals 1 minus cosine squared of theta. Okay, and all we do from here is we just move this over, subtract it from both sides. Okay, that gives us this, or we could subtract cosine squared to the other side, and that's what we would get here. Okay, so whenever you have these types of problems, if you notice this part, you just want to substitute that in instead, or this the same. Okay, so for example, simplify the following: 1 minus cosine squared of x. Okay, well, using our identity, okay, I'm going to erase this a little bit just so it's not so messy. Okay. Here we have 1 minus cosine squared of x. That is right here. So we can substitute that in with sine squared of x over sine of x. Okay? And sine squared of x, that's the same thing as sine x times sine x. We could divide that by sine x, and that would cancel, and all we'd get is sine of x. Okay. All right. Next one, we're basically going to use this and this to simplify. So 1 minus cosine squared of x, that gives us sine squared of x. Gosh, I keep saying theta. Over cosine squared of x. And we know that sine over cosine is tangent squared of x. Okay, and that comes from here. Tangent of theta equals sine theta over cosine theta. So if we have sine squared of x divided by cosine squared of x, that's the same thing as tangent squared of x. Okay, here again, we can look at this problem, and maybe you'd realized that both this term and this term has a sine of x. So we could factor out the greatest common factor, which is sine of x. So that would give us sine of x times sine squared of x plus cosine squared of x. Okay, and looking at our Pythagorean identity, sine squared of x plus cosine squared of x, this is just 1. Okay, so our answer would just be sine x times 1, or sine of x. Okay, and sometimes I don't put the parentheses around x, but either way it's the same. Okay, just kind of a shortcut. I'm kind of lazy, I guess. All right, next one. We have 1 minus cosine squared of x. Looking at this, that tells us that that is sine squared of x divided by cosine of x. Okay, this would be the same as sine of x over cosine x times sine of x. This is tangent, so we could get tangent x times sine of x. Okay, here we have 1 minus sine squared of theta. That would be cosine squared of theta times tangent of theta. Okay, that's pretty simplified. If you wanted to, you could do cosine squared of theta, and then tangent we know is sine theta over cosine theta. Okay, so this, or not squared, sorry. So we could cancel out one of our cosines, and that would leave us with cosine theta sine of theta. Okay, and the last one, now this isn't one of my favorites, but you could write it as sine theta cosine theta over cosine, or sine, sorry, why does it do that? Okay, undo. 1 minus cosine squared theta is sine squared theta. So we could cancel out the sine and one of the signs in the bottom, and that could give us cosine theta over sine theta. And that's like the opposite of tangent, so that could also be 1 over tangent of theta. Okay, but like I said, this isn't my favorite. Most of these, when we solve or simplify, I should say, most of them what you want to have is either a single thing or perhaps two things and have no denominators. Okay, so that's why I don't really like F, is because you can't really get rid of a denominator. Okay, but everything else is just a single, or like one or two things that are on the top. Okay, so that's the idea. Okay, if you have any questions, let me know.